Alright, so we're going to be working with force vectors and statics, and we're going to be using addition of a system and coplanar forces. And our question today is having a truck being pulled by strings. And our question is going to be to determine the magnitude of FA and its direction in theta so that the resultant force directed along the positive x-axis is 250 newtons. And yeah. Alright, so our given, we're going to start out with what is given. Okay, so our sum of f of x is positive 250 newtons. Our f of b equals 800 newtons. Alright, and to start this problem off, we're going to be using this. We're going to be breaking it down into components, and we're going to first be finding the sum of y, f of y. And to do that, we already know that it's going to be 0. The reason why we can assume that it's equilibrium, because it didn't say that there was any forces in the y direction. It just said it was being pulled by the x in the positive direction. So we can just safely assume that it's going to be 0. So it's going to be f of a y minus, and the reason why it's minus is because it's in the negative y plane right over here. So it's f of b y. So f of a y is going to be equal to f of b y. Okay? Alright. Alright, and so we're going to be trying to find f of by. So here is our triangle. Here's our f of by. Here's our f of b. And here's our 30 degrees right here. And to find that, we're going to be using trigonometry. We're going to be using the SO and the SOHCAHTOA. So sine of theta equals to opposite over hypotenuse. And we're going to be trying to find the opposite, which is f of by. So sine of 30 equals f of by over f of b. Correct? And since we're trying to find f of by, we're going to do f of b of sine 30 equals f of by. We're going to plug in our givens. So it's going to be 800 sine 30 equals f of by. Alright, so that's actually going to equal to 400 newtons, f of by direction. And now we're going to be finding the f of x, because that's our next unknown, f of bx. Okay, so here's a triangle, here's f of bx, here's our 30 degrees, here's our f of b. Okay, and then now we're going to be using the ka in the triangle, the trigonometry, because we're trying to find the adjacent right here. This is adjacent, this is opposite. So we're going to be using cosine of theta equals adjacent over hypotenuse, which is also cosine of 30, f of bx over f of b. Same same rule goes. We're trying to find f of bx. So it's going to be f of b cosine of 30 equals f of bx. Right there. So again, f of bx is 800 newtons. You didn't know that. And so it's going to equal out to 692 newtons. Do not forget the units, very important. Okay, we're going to go on with this. We're going to use now that we have f of ay and f of by equals 400, and then f of bx equals 692. That's what we have concluded so far. Now we're going to be solving for f of a now. So now that you remember, we have the sum of fx equals 1250 newtons. Correct? Alright. And what we also know, remember, that it also equals f of ax plus f of bx. Okay. And we know what f of bx was because we solved for it right there. So we're going to do 250 newtons equals f of ax plus this number right here. And then we're going to subtract that number over there because we are trying to find f of ax right there. Don't forget those newtons, those units right there, very important. It's going to equal 55718 newtons equals f of ax. Okay, now that we have f of ax, we also have f of ay. Remember in the beginning, we found that over here equals 400 newtons. So we can make a triangle. Here's our f of a triangle right here. We have f of ax, we have f of ay. This is y, f of ax. And let's see, if we were trying to find the hypotenuse, given that we do have the adjacent right here and the opposite, let's see, we can use Pythagorean theorem. It's not that intense. So, alright, there's the Pythagorean theorem. We're going to move this over so it's easier to find what c is. And I'm going to put it in terms where it would probably be easier for us to solve. So I'm just going to assume a equals ax, and then the b equals f of ay. And then basically you just plug in your knowns from here. Just plug and check. Alright. So f of a equals 55718 newtons plus 400 newtons squared. And somebody was telling me, well, wouldn't the newtons be square root too? Well, there's a square root here, so that cancels out. So the outcome is going to be the number of newtons that you get. It's going to be regular newtons. Don't forget those newtons. So we solve for f of a. Now all that's left is now we have to solve for theta. This is wonderful because we have f of a equals 686. We're going to be using tangent, inverse tangent. The reason because we're using inverse tangent is because we're trying to find theta. I'll do this quickly. Theta is OA, TOA, right here. And since we're trying to find theta, you do inverse tangent to both sides. And these will cancel out the tangent. You'll be left with the theta. And the reason why we're using tangent is because the opposite and adjacent one, f of x and f of y, would probably be more accurate than finding the hypotenuse because due to rounding error. So just on the safe side, you can use cosine and you can use sine, but I would just prefer to use tangent. It might be a little bit more accurate. Okay, well, here we go. So you do the inverse tangent of f of ay of f of ax, which will give you the phi, and that's going to equal for, there you go. And you may think we're done, but I mean, if we look back at this, the theta is over here, which in the book, this is the correct answer, but since this is over here, this would be the correct answer for right here, but theta's right here. So I'm going to just go with my instincts right here. Not my instincts, but my basic knowledge, knowing this, that this is a 90-degree angle minus phi, which is this part right here, from what we just found. So your theta actually should equal 35.7. There we go. And so your conclusion is that f of a 686 newtons, And this is 35.7 degrees, and we have just solved the tension and the theta that it's at. So congratulations. I hope you have a wonderful time and have a great day. Thank you so much for watching. Thank you.